Hello and welcome to trigonometry. This is probably one of the most important lessons in all of geometry. And we're going to start off a little bit slow. We're going to break this up into pretty much three-ish sections. And we're going to start with trig ratios. This is the foundation for all of trigonometry. And trigonometry is really just right triangle geometry. We've been working with right triangles this entire unit. And pretty much we are going to learn three new functions. These are your sine, your cosine, and your tangent. So sine is sine spelled S-I-N-E, but it's shorthanded S-I-N. Please do not say sin. You will be laughed at amongst your math teachers and your peers if you continue to say sin. Sine. Sine of this very, very, very popular symbol amongst geometry is theta. We call this theta. This is a Greek letter, and we use this in replacement for an angle. So if you ever see this, this is an angle. Theta will always represent an angle. So sine of theta will always be equal to a ratio. If you remember, a ratio is just a fraction. Fraction. Technically, it is a comparison of two values. And in this particular case, we're going to write it as a fraction, but it's simply put as a fraction. So it is the opposite side, opposite, over the hypotenuse. And if you remember, I have always said the most important side to identify is the hypotenuse. So sine of theta, or sine of an angle, is always going to be equal to opposite over the hypotenuse. Cosine of theta is always going to be the adjacent side. And if you know what adjacent means, hopefully this makes it easier. Adjacent means next to, and we'll break this down in a little bit. Adjacent means next to, so adjacent over hypotenuse. And last but not least, we have our tangent function. Tangent of theta, and notice all of the trig functions have theta or some kind of angle. This technically should be in parentheses. You'll see me do that for the most part throughout the rest of the unit. Tangent of theta is equal to opposite over hypotenuse. Now the question then becomes, what is theta? How do you identify theta? I'm going to move this triangle out the way just a little bit because we're going to need to identify some parts. I'm going to put this, I'm going to draw theta. Theta is just an angle, so we could actually make this angle theta or the one above it. It is just an angle. We typically don't use the right angle as theta because that's your right triangle, or your right angle for the right triangle. And we typically will just use one of these two angles that are left over. So if I call this bottom left angle theta, we could actually break this down. Now, simply put, there's a shorthand to all of this, which is kind of like a nice mnemonic. We call it SOHCAHTOA. So if you learn anything from this particular unit, just know SOHCAHTOA. I personally write it like this because it shows you the trig ratio, SOHCAHTOA. Some people actually spell it out, SOHCAHTOA. I personally like that top version of it just because you could actually see the ratio play out. Notice, though, that these don't have theta in them. So you have to keep in mind, all of these trig functions have theta involved. Okay? So, if we're looking from this perspective, I'm going to highlight this in red. I'm also going to write this in red. The most important side to identify is the hypotenuse. So I'm going to put hyp, H-Y-P. And then we know that this is going to be the opposite side because it is directly opposite of it. And remember what I said about adjacent meaning next to? Well, this is the side that is next to it. Now, for those of you wondering, isn't this side technically next to that angle? Yes, it is, but this is reserved for the hypotenuse, so we do not call that the adjacent side. The adjacent side that is not the hypotenuse side is the adjacent side. Okay? Now, here's the other question. What if I put theta here? Let's call this actually alpha. Alpha is another letter that we could use. I'm going to put alpha here. Well, alpha is a Greek letter for A, and we could actually do SOHCAHTOA, or the sine, cosine, and tangent of these trig ratios from this perspective. What's nice, though, is the hypotenuse doesn't change. That's why it's very, very important to identify. But if you notice, this side is alpha's opposite side. Okay? Because it is directly opposite of it. And then this side here is the adjacent side from the alpha perspective, from the blue perspective. So notice the way I wrote this out and I color coordinated it just a little bit to help identify. Alpha and theta both represent different perspectives of the triangle. So if we have a triangle, for example, let's call it just example 1. We're only going to do one example. And let's just do a triangle. And I asked you, for instance, if I put, let's say, 5 here, if I put a 12 here, then hopefully you should know that the last side of this is 13 because it's a Pythagorean triple. But let's pretend we're working from this angle's perspective, okay? Then we could say, oh well, this has to be 13 because it's a Pythagorean triple, as mentioned. And if I wanted, let's say, cosine, let's do all the trig functions. Sine of theta. Let's do cosine of theta. And then let's do tangent of theta. So this is what I mean by we shorthand them. Sine, S-I-N, cosine, C-O-S, tangent, T-A-N. So call them by their full names whenever you say them. Don't say cos or cos. Don't say tan. Say it fully. So sine of theta is the opposite over the hypotenuse. Or if you're using the SOHCAHTOA version here, it becomes a little easier because you can look for the opposite side and the adjacent, the hypotenuse side. So if you want to label them, absolutely. Label your hypotenuse, label the opposite, label the adjacent. And now you could do this. Opposite over hypotenuse for sine is 5 over 13. So if we're only solving for the trig ratio, then you just write the ratio out. Okay? Cosine would be adjacent over hypotenuse. So we would say 12 over 13. And last but not least, tangent is the opposite side. I should probably zoom out a little bit. The opposite side over the adjacent side, which is 5 over 12. Okay? So that is how you would write a trig ratio given all three sides of a triangle. Now, even if you're given 2, theoretically you could still solve for that third one as we did here. We said, oh, okay, 5, 12, and 13. It makes a lot of sense to actually have that 13 there, and we could solve for all the ratios as needed. All right, so that's your intro to trig ratios. Remember, a ratio is just a fraction. All we are going to do is write the fraction out. Some value over another value. Okay? If you do have any questions, please let me know, and I'll see you in the next one. Bye.